Welcome, everyone. My name is Csaba Fitzl, and the presentation is Knockout Win against TCC, also known as 20+ new ways to bypass your macOS privacy mechanism. My name is Csaba. I'm currently working for Offensive Security. I'm right now the lead content developer for our macOS control bypasses training. I used to be a red and blue teamer for 8 years. Before that, I do macOS bug hunting in my free time as a hobby, also as part of work. Now I'm married, have 2 kids, and I love hiking and trail running. My co-presenter is Wojciech. Unfortunately, he couldn't join us due to some health issues. So he recorded his part, and we will play it back now, and then I will pick up from there.
Hey, I'm Wojciech Regula, and I'm head of mobile security at SecuLink. Unfortunately, due to my bad health condition, I couldn't be there with you at Black Hat in person. However, I will be still able to point the TCC from the recording. So I'm a blogger, wojciechregula.blog, where I, of course, document my iOS and macOS security findings. Mostly focused on iOS and macOS application security. Somebody of you may also know me from iOS Security Suite that I'm creator of. That's a free open source Swift library that helps developers making sure that their application is run on secure iOS devices. And I'm also engaged in macOS environment security testing, macOS red teaming, etc. So this is the second part of our presentation we gave with Csaba last year on Black Hat in the US, where we focused, of course, on bypassing macOS privacy mechanisms. So yeah, that's the second part, the research continuation. And that's because that's the second part. In the first point of the agenda, I'll just quickly remind you what is TCC and what are the basic privacy fundamentals of macOS. If you are interested in learning in details how it works, please check our first part of this talk. So yeah, that we will then focus on technical stuff, on TCC bypasses, and as you can see here on the slide, there are a lot of new TCC bypasses. And at the end, Csaba will cover some new security improvements released in macOS Ventura. So let's start with I think the most fundamental macOS security mechanism, that is system integrity protection, based on sandbox kernel extension. So on macOS, if you have root, you are not a god, because even if you are root, you cannot do anything with your operating system. Because the SIP will restrict access to many directories, will deny debugger attachment to processes signed directly by Apple. You may not be able to change the contents of some restricted, crucial from the system perspective files, etc., etc. And when the system integrity protection is turned on, there is a new mechanism that's also turned on, which is transparency, consent, and control, which the abbreviation is, of course, TCC. When you, for example, open a new application that will try access some privacy-sensitive resources, like for example your contacts, your address book, you will see a problem because the operating system wants to know if there is a clear user's consent to give the application some access to your privacy-sensitive resources. And if you open privacy and security settings, you will see that there are a lot of different resources that are controlled by the operating system and the TCC mechanism. Even if you go to the automation tab, you will see that TCC can be really granular, because we can even control what application can control which other applications. And yeah, TCC is really huge nowadays, and we observed that when Apple released a new major macOS version, there are new TCC checks that are still added to the mechanism. Yeah, so that's really huge and will be probably even more big. Okay, but that was the quick recap of the theory. Let's now focus on the exploitation. So 1 year ago, we showed you that there was a huge possibility to attack TCC via plugins loaded to the application's contexts. And yeah, here we go again, 1 year later, still there was a possibility, but now via the device abstraction layer plugins. So those plugins are loaded when applications open camera stream using the core media I/O. And those plugins are stored in the library core media I/O plugins directory, which is not protected with system integrity protection. And those plugins are written, let's say, the old way. There is no middle layer between the core media I/O and those plugins. So they are directly loaded to the process context, which allows us to, if we are able, of course, to load the plugin to the vulnerable application, we can control the whole application and use all of the permissions that were already granted to that app. So let's create a plugin. It's a bundle, standard bundle with dynamic library that will be, of course, loaded. We have to add those two CF plugin factories and CF plugin types entries to the info palace of that bundle. And using the simple old Objective-C constructor trick, so the constructor is executed when the plugin is loaded to the context of the main app is executed. So in this constructor, we are able to execute our own code. And yeah, after I created that plugin, I decided to grab the file system for all Apple's applications that are standard installed on macOS that have the private TCC service camera permission granted. Because if an app has the private TCC permission entitlement, the app doesn't have to ask for access to the granted already private resources, because there is a private type, right? The Apple controls which their app don't have to ask the TCC for accessing the private resources. So I grabbed for all those applications with that private entitlement, and I decided to open them all. And yeah, as you can see, quickly, almost instantly, I got 5 hits, which is a big deal for somebody participating in Apple Security Party, I have to say. So I was that happy that I decided to go AFK and I went on vacation. But coming back to the exploitation, the idea is really simple. Just create a malicious plugin, save this one plugin in DAL directory, and open all vulnerable applications with interesting entitlements. So one of those 5 hits was photo booth. So let's take a look at its entitlement. Camera, microphone, address book. Looks good. Now let's see the demo. I created the plugin and installed in the directory I told you. Let's now open the photo booth application. Under the hood, the plugin is loaded. And as you can see, I made a screenshot of that application. So yeah, I was able to access users' camera without raising any TCC prompt. But from those 5 hits, I think the most interesting one was the contacts application, because as you can see, there are a lot of different TCC permissions, and one of those permissions was TCC manager, which allows us to fully take over the control over the whole TCC database. So let's take a look at the demo. I open the contacts. I will do it also manually to show you where the code is actually executed. As you can see, in full disk access, only those apps have the permissions granted. And when I create a new contact manually and I open the camera stream, the plugin is now loaded and the terminal application has been added by my code because I have the full control over the TCC database. So yeah, that's the ultimate TCC bypass vulnerability. So those 5 findings had 5 different CVEs assigned because in all of them the hardened runtime had to be turned on. The second bypass I wanted to share with you is via launch services. But before we start exploiting it, let's focus on what MacL is. So when you open terminal and want to cut, some file from a directory here, for example, from documents that is protected by TCC, that operation should not be permitted because you didn't grant access to terminal. But if you drag and drop the file to the terminal, you will see that now magically the terminal has access to that file. And that's because the MacL extended attribute, which we can see with the xattrib -l to see the com apple MacL extended attribute. So this attribute is managed by Sandbox. It cannot be modified by user or even root. And the idea of MacL is to have the clear user intention that user wants to open this particular file, and that particular application has to access this file without raising additional TCC props. So the MacL extended attribute is applied in 2 situations. When user drags and drop file to the app, or when user double clicks on a file, so the application that is responsible for the file will automatically open it. So you tell me that MacL extended attribute is applied when user double clicks file. Well, so after 2 years of researching TCC, I found out that the only thing required to bypass the whole mechanism is just to register a malicious app to handle all file extensions and call launch services to open the juicy files, right? It's a ridiculous bug, really. That's my most favorite bug in TCC I've ever found. So let's take a look at demo again. MacOS 12.2, system integrity protection is enabled. You will now see in security and privacy that there are no additional privileges granted to the bypass TCC via me application that we'll be using, the proof of concept app. And now when I open it, you can see when I click on address book, it's copied to the TMP directory, and the same with iMessage. And when we go to the temporary directory, you will see that we actually have access to those files, which shows that we were able to bypass the TCC. Of course, the new CVE was granted for that issue. Another vulnerability that I wanted to share with you is the TCC bypass via SQL tracing mechanism. So there are a lot of small applications on Mac that use under the hood SQLite 3 to store data. Some of those applications are apps that have resources protected by the TCC, like for example mail, contacts, notes, iMessage, etc. And all of them use libSQLite 3 dynamic library that, of course, handles all of the SQLite free stuff, but the framework, the dialog, respects the SQLite auto-trace environment variable. When it's set, it logs all of the used SQL queries. And on Mac, there is a simple way to enable environment variable globally. So with just launchctl set env, I was able to do so. And again, I started using those applications that use the SQLite 3. One of the examples, contact. When I started creating one contact, the details were locked. The same with mail, because mail has to store somehow your mails that are sent locally on your disk. They are saved in SQLite 3 database. So yeah, the SQLite query were locked. Again, returns daemon. So when you use iMessage, this daemon stores the information about your recent contacts. With notes, the situation was a bit harder, but it wasn't really hard to attack. So if you create a new node, you will see that the data is visible in SQL queries. However, if you just unhackify this data, you will see the context. And funny thing is that any application that is not sandboxed on Mac can access the logs. So there is no special additional entitlement required to do so. Any app could access these logs. Okay, and the next vulnerability is to bypass TCC via iCloud. So some of the normal TCC protected data is by default synchronized with iCloud. However, in this part, we won't even touch the TCC protected data, I mean by attacking the TCC itself. We will extract them directly from the cloud. So I identified two interesting applications, GarageBand and iMovie, that had both Apple private iCloud account access entitlements. And the GarageBand additionally disabled library validation. So with the private iCloud account access entitlement, we can communicate with an old C-written XTC API provided with the iCloud helper service. And that service will happily provide us with iCloud tokens with nicely apps. But in order to do so, we have to have the code execution within the privileged processes context, right? So in GarageBand, the attack was pretty easy because I just used the standard dialog proxying attack to modify one of GarageBand's framework and execute code within the GarageBand. In iMovie, it was even easier because iMovie didn't have the hardware runtime turned on. So with just built insert libraries variable, I was able to inject my dialog to the iMovie context and execute code within it. So when I did exploited those two applications, that was the JSON returned from the iCloud helper service. And as you can see, there are a lot of iCloud tokens that were provided to me. I created also a demo that will exploit the location service. So if you provide the stolen token, under the hood, the script will refresh the find my session and will have the JSON returned from iCloud. So latitude and longitude of myself without raising any TCC prop, right? So yeah, we were able to exploit it. The idea for other resources synchronized with iCloud is the same, so I just showed you the exploitation of location services. And of course, those issues are now fixed. You may ask, but Wojciech, why there are 2 CVs for each vulnerability? Because again, Apple forgot about downgrade attack, so it was still to exploit it by just using it against the older version of it. But now it's all fixed. That's the end of my part. Thank you very much.
Thank you. So you might think already that TCC is fully broken on macOS, and you haven't even seen the second half of the presentation. So let's continue with some more bugs. So the next round of vulnerability class, we called it TCC bypasses using sysadmin tools. I really like the rule of diversity from Eric Raymond's 17 Unix rule, which says, developers should design their programs to be flexible and open. This rule aims to make programs flexible, allowing them to be used in other ways than their developers intended. And I think this idea catches this part really well because we use sysadmin tools in the way they were never intended to be used. Some of these tools have very powerful entitlements, and basically they will allow us to either fully or partially bypass TCC. So the first one, called ASR, which is the Apple Software Restore utility, basically it can be used to restore and clone full disk images and has some very powerful entitlements. And I had the idea, okay, TCC restricts us from accessing certain parts of the file system, but what if we take the entire file system, clone it somewhere, and then just access that disk or image? Turns out that ASR is a super buggy tool. I really feel sorry for all the Mac admins who have to use it. It's basically broken on every single version in a different way. I actually had to search for how to actually use it, and I found a very good blog post from one of the Mac admins which says, okay, these are the steps how you use ASR on Catalina. Because ASR is very sensitive to all the APFS disk layout. The problem was that I was already on Monterey and not on Catalina, so the steps he described didn't work anymore, so I had to find my way through. I eventually managed to make an APFS layout and disk layout, which was happily accepted by ASR. And simply as is, I could basically clone the entire disk to another partition, then open that partition, mount it, and then list all the private stuff I wanted. So on the screen, we can see that I can access messages on the newly created partition, but I cannot access it on its original location. The next one is Time Machine. Time Machine is Apple's backup utility. If we back up to an APFS disk, it will use snapshots to make the backup. Now, by default, it seems to be very well protected by TCC. So if we try to go and list our backup volume in the hope that we will find private files there, it will not be permitted. If we try to list the snapshots of that backup, it will not be permitted. So it looks good, but it turns out that if we start to browse the time machine backups in Finder, Finder will mount those backups in a new location under the hood, which is under volumes/.timemachine, then a GUID, and then the backup date. And that location will not be protected by TCC. So if by any chance the user browses his backups for restoring something or whatever, at that point we can access all of his files. Unfortunately, but this has been fixed. The next one is Apple Mobile Backup utility. This is a small utility to backup iOS to macOS. Now, the default backup location is under the user home folder, library, application support, mobile sync backup. This is protected by TCC, as it should be because iOS backups contains private information, of course. But can we backup somewhere else? Turns out we can. So we first need to get the ID of our iOS device. We can use the system profiler utility for that. And then we can call the Apple Mobile Backup utility with the --root option. And with the --root option, we can specify the root directory for the backup. So we can basically backup to the temp directory. And once the backup is complete, we can access those files. That works anytime the user plugs in his or her iPhone to the machine, and at that point we can access all the private information. Now, Apple came back to me that was at Ventura Beta 5, and they said we fixed it. And it turned out what they did, they removed the root option from the utility, which seemed to be nice on the surface, but it turns out that the Apple Mobile Backup utility, it doesn't have any specific entitlements to do the backups first, and it uses the device link private framework. Now, this private framework has the function to set the root folder for the backup location, and the framework still had this function. So what someone can do is load this framework on its own and call this function and basically mimic the utility on his or her own program. So this was one. The other thing, I could take an old version of Apple Mobile Backup, put it on the latest Ventura, run it, and it will still work. So we are back to square one, and I'm pretty sure Apple was looking somehow like this. Okay, so this is not good. So they re-architected the entire fix, and ultimately they sacrificed usability for security. Sorry for that. Someone called me out on Twitter that, hey, did you break our automated backups for iOS? And I was like, no, I haven't done anything. Like, is the CVE related to the broken feature? And I was like, probably not, maybe. And I started to look into it, and eventually it turned out that yes, they can blame me for that. So what Apple did is whenever you want to back up your iOS device, you need to enter your passcode on the iOS device for the backup to happen. And this breaks any automated backups, unfortunately. I hope this will change. So, for example, if the backup is encrypted, then there is really no bypass here because the backup will be encrypted, and regardless the backup location, an attacker cannot decrypt it. So in that case, I think asking for a passcode is not necessary. We will see if it will be changed in the future or not. The next sysadmin tool, remote management, or Apple Remote Desktop. We can enable this service as root, so it requires root if it's not enabled. And the Apple Remote Desktop agent, the ARD agent, has a system policy all files permission, which means full disk access. So it can write files anywhere. So what we can do, and here's a video of the exploit. For this, we need to be root. So on the video, I'm showing that the TCC database, it's empty. It doesn't grant permissions to anything. Let's try this again. So the TCC database is empty. What we will do is create a new user. Again, we need to be root for this. It can be any user. It will be an admin user. And then we will enable remote desktop service. We could do this without any specific permissions besides being root. And once it's enabled, OK, it keeps crashing. So basically what happens is once the new user is created and remote desktop is enabled, we can use the remote desktop utility to copy a file to the file system, remotely overwrite the existing TCC database, and basically take over TCC with any new rules we want. We cannot access like the user desktop with enabling remote desktop this way, but we can still copy a file remotely. And this was fixed mainly at the sandbox and backup by Apple. There are still a few that being fixed, so maybe in a future Black Hat or conference, we can present those. The next one is TCC bypass through mounting. The idea is basically that TCC protects many directories, and we mount a new disk image over this directory, and maybe drop a new configuration file, like a new TCC database, or let the system write there something, and then we can read it back by unmounting it. I heavily abused this back in 2021, and eventually Apple learned the lesson that they now properly protect most of the directories from mounting, and I said most of them. Turns out not all. So TCC has two main databases, one for the system process and one for the user. Turns out there is a third one which I wasn't aware of, and it's only used by the location services daemon. And it's not a database, but it's a property list file, but it acts as the database. I have no idea why this is separately and why these permissions are not in the main TCC database. I think it should be. Anyhow, this location wasn't protected. So what I could do is create a new custom plist, put it in a disk image, and mount this disk image over the var.db location, the directory, and grant any application access to location services. And then there was a very interesting bug. I call it hard link confusion. So some directories, like documents, address book, as we saw earlier, are protected by TCC, so we cannot read and modify files that exist. But we can create new files there, which is weird at the first time, and I frequently got asked this question, is this normal? Yes, it is. It's confusing, but it's still OK, because if you create a new file as an attacker, you don't really access the user private stuff. So it's OK. It's weird, but it's OK. The second thing is that we cannot create a hard link pointing to a TCC protected file, which is good because if the hard link is in a different location, we could access that file immediately. But what if we combine the two? So is there like some sort of check race? Here turns out that yes. So what we can do, again, we try to list documents, we try to list the address book, and we can see that it's not permitted. But, and which was not right, what we could do is create a hard link inside the documents directory pointing to the address book. This shouldn't be shouldn't work, but it did work. So at that point, we have a hard link pointing to the address book from the document. So we still cannot access any of them. But now if we try to access the address DB in documents, we will get a pop-up that terminal wants to access your documents. And now if the user approves it, we can access that file. We still cannot access the address book, but we can access the hard link. And this is a problem because the user thinks that he gave access to the documents folder, but not the address book, but we can actually access the address book. It's been fixed, again, in the sandbox. Now let's switch to Ventura changes quickly. One of the new TCC features is application bundle protection. Basically, TCC will now prevent applications from modifying other applications. This has been abused way too many times for pawning Electron-based application or simply malware by dropping files inside other applications. So this is good. Unfortunately, I managed to bypass this 3 times. So this is still being fixed. The other thing is the endpoint security clients. They used to require full disk access permission for them to operate. And I had another talk at Objective by the Sea about the Achilles heel of endpoint security. Basically, it was really easy to revoke this permission for endpoint security clients, and you could disarm any security software on a Mac. So this went back and forth between me and Apple, and eventually they redesigned the way endpoint security clients got this permission, and now instead of full disk access, they require this endpoint security client permission, but it still shows up under full disk access, which allows some confusion. And it turns out that they made a mistake, and Mikey found it that if you do the upgrade on Ventura beta, then there will be two entries now for the endpoint security client, and it will be confusing for the process, and eventually the endpoint security client will not work. So my friends, Patrick Wardell, Thomas Reed, and anyone who writes endpoint security software for Mac, they were overwhelmed with bug reports that, hey, your application is broken, and articles like this started to show up. My request to Apple, please don't break stuff by fixing my stuff. This is not the fame I want. Other improvements, these are not TCC specific. It was a very common attack to do downgrades, as we saw earlier. So basically, we can either use an old binary from another older OS, or we can take an application, copy it out from its location, embed the plugin, and run it. There are many blog post talks about it. So one of the improvements is Trust Cache. This is coming from the iOS world, and it's only for Apple Silicon. The idea is that the Trust Cache will have all the hashes of all the Apple binaries present on the system. And if your binary is signed by Apple, it can only run if it's present in the Trust Cache, otherwise not. So it will prevent any downgrade attacks. So I cannot take, for example, the old Apple mobile backup utility from an old system because it will be blocked, because it doesn't present in the Trust Cache. So this is pretty nice. Unfortunately, it's not on the Intel-based version, but I guess that will go away anyway in a few years. And the second big one is launch constraints, which basically controls from where and who can start an Apple-signed binary on the system. So, for example, if an Apple-signed daemon meant to be started by launchd, only launchd can start it. So I cannot start it anymore from the command line. And the other big thing is that I cannot copy out an application from its trusted location and run it. So it has to reside under system, which is pretty nice. More from it is written by Linus Henze on his blog post. Thank you very much. That was all. if there are questions, I'm not sure if I have time for questions, but you can find me here afterwards. Thank you.